Welcome back, everyone. Today I'll be doing idempotent and orthogonal matrix. Let's get started. In linear algebra, if I have a matrix A, it is said to be idempotent because A squared is equal to A. What is that telling us? It's telling us that a matrix which when we multiply by itself yields itself. So A squared, remember A squared is A times A. So when I multiply this and I am getting the matrix A, this is the property I'm looking for to know that it is idempotent. Now let's look at an activity. Determine if the matrix A is idempotent. Now, what I need to do is to show that A squared is equal to A. That's all we need to do. A squared is equal to A. A squared means I will be multiplying this matrix A twice. So matrix A, I have -1, 2, and 4 in my first row. And then in the second row, I will have 1, -2, -4. In the third row, I have -1, 2, and 4. The same thing will be in the next matrix here because I'm doing A squared. So I'm going to have -1, 2, and 4, followed by 1, -2, -4. And the next one would be -1, 2, and 4. So now all I need to do is just multiply. When I multiply, we multiply row by column. So I will divide the first matrix into 3 rows and the second matrix into 3 columns. So multiplying this, let's go ahead and do this. So I'm going to say the first row times the first column. So I say -1 times -1, that's +1. So I go ahead and write 1. Then 2 times 1, that's 2. So I'll write +2. Next, I will say 4 times -1, that's -4. So I will have a -4 here. Next, I will multiply the first row by the second column. So proceeding to do so, we have -1 times 2, that's -2. Then we have 2 times -2, that's -4. So I have a -4 here. And finally, I will have 4 times 2, that's 8. So I go ahead and I have my +8. Next, I will go ahead and multiply the first row by the last column. So -1 times 4, that's -4. Then 2 times -4, that's -8. So I have my -8 here. Then 4 times 4, that's 16. So I will write +16. Now I'll be moving to my second row. So second row times first column. So 1 times -1, that's -1. Next, I will say -2 times 1, that's -2. Finally, -4 times -1, that gives me +4. So I will write +4. Next, I will multiply the second row by the second column. So 1 times 2, that's 2. Next, I'll multiply -2 times -2, that's +4. And lastly, I multiply -4 times 2, that's -8. So I'll write my -8 here. Next, I'll multiply the second row times the last column. So 1 times 4, that's 4. Then I'll multiply -2 times -4, that's +8. Then I multiply -4 times 4, that's -16. Finally, I am going to multiply the last row by the column. So I have the last row times the first column. So -1 times -1, that's +1. Next, I'll go ahead and say 2 times 1, that gives me +2. So I'll write +2 here. Then I have 4 times -1, that's -4. So I have my -4 here. Next, I multiply the third row by the second column. So -1 times 2, that's -2. Next, I multiply 2 times -2, that's -4. Next, I multiply 4 times 2, and that's 8. So I'll go ahead and write +8. Finally, I multiply the last row by the last column. So -1 times 4, that's -4. So I have a -4 here. Next, I will go ahead and multiply 2 times -4, that's -8. So I go ahead and have a -8. Next, I say 4 times 4, that's 16. So that gives me +16. So that means what I have here, 1 plus 2, that's 3, minus 4, that gives me -1. So I go ahead, write my -1. -1 minus 2, that's -3, plus 4, that gives us +1. So I go ahead, write my +1. 1 plus 2, that's 3, minus 4, that gives me -1. Let's move on to the second column. So I have -2 minus 4, that's -6, plus 8, that gives me 2. Next, I have 2 plus 4, that's 6, minus 8, that gives me -2. And finally, for this column, -2 minus 4, that's -6, plus 8, that gives me +2. Last column, we have -4 minus 8, that's -12, plus 16, that gives me 4. Next, I have 4 plus 8, that's +12, minus 16, that's -4. And finally, -4 minus 8 plus 16, that gives me +4. As you can see, when I do a square, multiplying it, I am getting a. So yes, it is idempotent. Orthogonal matrix. This matrix is a real square matrix whose columns or rows are orthonormal vectors. Now, what we are saying is that it's a square matrix. It has the same amount of rows and columns. So that's why I have n by n. Same amount of rows and same number of columns. So an n by n matrix is said to be an orthogonal matrix if A transpose is equal to I. So the key thing is that we have the same amount of rows and columns, which we consider to be called a square matrix. Now, remember, A capital T, A with a capital T is a transpose of A. I is the identity matrix. And just remember, in particular, an orthogonal matrix is always invertible. And we say A inverse is equal to A transpose. Now, an activity, I have a small activity here where I need to show that it is, well, in this case, I need to prove that it is an orthogonal matrix. Property for it is that when I multiply A times A transpose, I should get I, which is the identity. Since this is a 2 by 2 matrix, then it's telling me that I am going to get the identity 1, 0, 0, 1. That's what I'll be getting. So I know that A is cos x, sin x, minus sine x and cos x. So this is A. The transpose of this, I'm going to change the first row into a column. So I will have cos x, then minus sine x, followed by the second row, I will change into a column. So it becomes sine x, cos x. Now I'm going to multiply. So we multiply row by column. So divide the first matrix into 2 rows and the second matrix into 2 columns. So the first row times the first column, that's what I'm going to do first. So I multiply cos x times cos x, that gives us cos square x. Minus sine x times minus sine x, negative times negative, that's positive, and sine x times sine x, that gives me sine square x. So I'll have plus sine square x. Now multiplying cos x and the minus sine x times the second column. So the first row times the second column. So cos x times sine x, that gives me cos x sine x. And please note, you could have written this as sine x cos x. And then minus sine x times cos x. You can write minus sine x cos x, but due to consistency, because I wrote cos x first, that's why I am going to write cos x sine x. So remember, I can multiply minus sine x times cos x is the same thing as minus sine x cos x, but due to consistency, that's why I've written cos x first. Now, the second row, I'll multiply by the first column. So I'll have sine x times cos x, that gives me sine x cos x. And then I have cos x times minus sine x. And here you should be saying to me, if I could have heard you, you would have said, Miss, we have to be consistent. So it would be minus sine x cos x. If you said that, good job. You're following. If not, you can always replay this and, go back over this. Now, I'll multiply the second row by the last column. So I have sine x times sine x. That gives me sine square x. And cos x times cos x, that gives me cos square x. So I'll have plus cos square x. Now, you should be seeing that I have some cancellation. These two cancel to give me 0. These two cancel to give me 0. And this is identity. Cos square x plus sine square x is 1. So this is 1, 0, 0. Once again, this is an identity. So this is 1. Here you can see that I have the identity. So once you have A times A transpose and you arrive at the identity, that's how we know that it's an orthogonal matrix. Thanks for watching, guys. Don't forget to like and subscribe to my channel. And if you have more questions, leave a comment below. Have a great day.